evaluate some logarithms here. Okay, so we don't have the whole expression, and we need to find out the value of this without using our calculator. Okay, just using what we know about powers and numbers and doing some mental math here. Okay, so log base 3 of 9. What that is saying is 3 to some power is equal to 9. Okay, what that's saying is 3 to some power is equal to 9. Well, what power would that be? The second power, 2. 3 squared is equal to 9. So I don't have to do anything with my calculator. I know that the value of log base 3 of 9 is 2. Okay, log base 4 of 64. That's saying that 4, the base, to some power is equal to 64. Again, what power would that be? 4 cubed is 64. So log base 4 of 64 is equal to 3. Now, number 3 is a little weird. Now, I'll admit it. Okay, it doesn't happen very often, bless you, that a square root shows up inside of a logarithm, but it does happen from time to time. So that's saying 7 to some power is equal to the square root of 7. Okay, well, 7 to some power is equal to the square root of 7. What power would that be? The 1/2. Because the square root is equivalent to the 1/2 power. Power over root. Log base 8 of 8. Log base 8 of 8. 8 to some power is equal to 8. Okay. Pretty common sense, right? That should be 1. 8 to the first is 8. So, here's a little lesson. When the base of your logarithm is the same as the number inside the logarithm, the answer is 1. The answer is 1. When those two numbers are the same, the answer is 1. Okay, number 5. Log base 2 of 1/8. This one's going to take a little bit more thinking. 2 to some power is equal to 1/8. So I'm actually going to write that over here. 2 to some power is equal to 1/8. Well, when I see this problem, I'm looking for a connection between 2 and 8. And there is a connection. You involve the exponents. 2 to what power is 8? Third. 2 cubed is 8. Okay? But it's not equal to 8. It's equal to 1 over 8. So how could we maybe get that 8 in the denominator? Negative exponent. Okay? 2 to the negative third is equal to 1/8. So that means that log base 2 of 1/8 is equal to negative 3. Alrighty. Log base 6 of 1. Log base 6 of 1. So 6 to some power is equal to 1. Well, clearly it's not like 6 times 6 or 6 times 6 times 6. That's just getting bigger. 0. Anything to the 0 power is 1. So, another property of logarithms you need to know here. Excuse me. The log, the common log, the log base mean, the natural log, if 1 is the number inside the logarithm, your answer is 0. That's the only way you can get a 1 as your answer. When you're raising something to a power, the only way you're going to get 1 is if that power is 0, unless your base is 1. And that's just not weird. Okay? Number 7, the common log of 1. Okay, the common log of 1. We don't have a base there. Remember that that's understood to be 10. Okay, but it really doesn't matter what the base is. That's what I just talked about there. What's our answer? 0. Anytime 1 is the number inside the log, the answer is 0. Number 8, the common log, no base, of 1,000. Well, again, the base, if it's not there, it's understood to be 10. 10 to what power is 1,000? Third. Okay, 10 squared is 100. 10 cubed is 1,000. So this answer is 3. Okay, just a few more. Log base 2 of 2 to the 4th. Okay, 2 to some power is equal to 2 to the 4th. Well, kind of a no-brainer there. What is it? 2 to some power is equal to 2 to the 4th. 4. 2 to some power is equal to 2 to the 4th. If the bases are the same, their exponents have to be the same. So what would be the answer to number 10? 7. 3 to some power is equal to 3 to the 7th. Bases are the same, their exponents must be the same. Now, very rarely do we have a fraction as a base. This is log base 1/2 of 1/2, but every once in a while, once in a blue moon, it will show up. But let's think back to our properties a minute ago. If the base and what's inside the logarithm are the same, what's the answer? 1. Because that's saying 1/2 to what power is 1/2? That's the first power. All right, last two. Log base 8 of 2. Ooh, got to think about this one for a second. 8 to some power is 2. We've been using this relationship between 8 and 2 here for a while. Okay, now, can I raise 8 to a whole number power and get 2? No, right? Because it's 8, 64, 243. It's just going to keep getting bigger, not 243. Why do I think 8 cubed is 243? 512. I really don't know why. Anyways, sorry. So it's not going to be a whole number. We're raising a number to a power and we're ending up with a smaller number. So how could that possibly happen? Okay. Yes, 1/4 of 8 is 2, but that's when we're multiplying. We've got to think about an exponent. But you're on the right track, because it's going to be a fraction. 1/3. 1/3, because the 1/3 power is what? The cubed root. The cubed root of 8 is 2. So this answer is the 1/3. 8 raised to the 1/3 power is 2. The 1/3 power is the cubed root. The cubed root of 8 is 2. All right, let's look at this last one. This one's a little, like the most complicated one we have. Log base 2 of the cube root of 4. Okay, so that's kind of weird. 2 to some power is equal to the cubed root of 4. Okay, so first of all, we're dealing with exponents, so I want to change that root over there to an exponent, first of all. So I'm going to change that to 4 to the 1/3. But my bases aren't the same. I got base 2 on one side, I have base 4 on the other side. Now, is there a relationship between 2 and 4? Yeah. 2 squared is 4. So, how about we write 4 as 2 squared? We're going to rewrite the base 4 as 2 squared. Now, this expression here on the right side looks a little weird, doesn't it? Power to a power. What do we do with those exponents? Multiply. Lovely. 2 times 1/3 is 2/3. So, what is our answer to this logarithm? The 2/3. 2 to the 2/3 is equivalent to the cube root of 4. complicated, but it's manageable.
All right. So,
Bill had a question earlier. How do we change the base on our calculator? Now, like I said, the newer calculators will allow you to change the base, but we can still do that on our calculators, on the older, the TI-83, okay? If you have a base other than 10, we call this using the change of base. So if we have something log base b of x, so for example, log base 7 of 5, we can evaluate that in our calculator using the common log. You would type it in as log of x divided by the log of the base. Okay, I call it the log of the big number over the log of the base. Okay, so on the left side you've got base b, on the right side you're using the common log of base of 10. So
to evaluate log base 7 of 5. Now we can't figure out
7 to what power is 5. That's not one of the nice even ones. Okay, we can't,
without a calculator, we really cannot figure out 7 to what power is 5. But we can get its value by doing the log of 5 divided by the log of 7. Now you have to make sure
that you close your parentheses. You have to close the parentheses after that 5, because if you don't, it's going to stick this log of 7 into that first logarithm.
So you got to make sure close parentheses after the 5 divided by the log of 7. So you can check it. 7 to that power is 5.
Okay, so that is how on the TI-83s to evaluate logs that have a base other than 10 or other than the natural log. That's how you handle it. Log of the big number divided by the log of the base.
Okay, so let's spend just